to Robotics Lab, Nttf Bangalore Center. Hi everyone, I'm Johnny Asher, Senior Training Officer, and my friends Mr. Manigandan and Mr. Abhishek Kumar, Training Officer, NEC Bangalore Center. Today, we are going to demonstrate moving a robot manually with the help of a Fanuc industrial robot. Here, we are using Japanese robot Fanuc LRMet 200 ID 4S for our training purpose in all the centers of Nttf. I hope you can view the model number. Now let us see the features of the robot. This is a standard 6-axis robot which can rotate in 3D workspace in the form of 3 linear X, Y, Z direction and 3 orientation. Now you could see the linear in X direction which moves right and left completely. See how it's moving? And then now we are going to see the movement along the Y direction. See, it moves front and back. I hope it looks amazing. Now we are going to see the third movement, which is the Z-axis movement, which goes up and down. So it is gorgeous to look at it. And apart from this, we have 3 orientation along the same X, Y and Z. So this is the X orientation. And then we have the fifth one, which is the Y orientation. And finally, we have the last orientation, which is the Z axis. This is Z orientation. And now you could see the end effector point is trying to move. And it can rotate in different axes. Now, as you all observe, this is a complete 6-axis robot movement. Now, we should also know that it has a maximum payload, which is around 4 kg, which it can carry. And that is represented by the letter 4S from the model number, which you could see it on the screen. And similarly, the maximum speed designed to operate the robot is 2600 mm per second. See how it's moving. And the maximum reachability of the robot's end effector is 550 mm horizontally. Look at this, how it is moving horizontally. So this is the reach where the robot can go ahead with. And as we all know, the robot is always programmed with the help of a device called as a teach pendant. So this is a device which you could see it on the screen. So with this we can operate the robot. And the first thing which we have to do is put the mode in a manual, which is called as a T1 mode. Now I'm going to demonstrate the movement of the robot with the help of the teach pendant which you saw. We also have another part which is at the rear side of the teach pendant, which is called as a dead man switch. This is also called a safety switch. This is to enable the movement of the robot. Normally, the robot is moved manually and each point is recorded. Now, I'm going to demonstrate showing you how the robot is moving from one point to the next automatically. Now you could see the logo of Nttf onto the board, which is at the bottom. Now the robot is trying to move along this path. See here, the robot is moving manually and it also does automatically to its part. Now it is coming to the point where it has to start with. Now it is tracing the path along the pathway. Hope you all enjoyed with this. The next part is which is called as the end of arm tooling, which is called as EOAT. So that is also one more part which is trying to trace it. It is also programmed with this teach pendant. This includes tooling of all applications and grippers. And here is a part we try to connect the grippers where it can pick and place the corresponding object which has been required to. And above all, you all should know that we need to clear the fall completely. So there is an option where we are supposed to press the reset key along with the dead man switch to clear the fault. So always follow this step to clear the fault. And now we have altogether there are 6 joints in this movement, and all these movements are controlled by a servo motor. So there are altogether 6 servo motors which are controlling it. As it is a 6-axis, we can see it has 6 joints. Initially, we need to set the coordinates to jog frame. So that is required to go ahead for the complete system of operation. So very first is the J1 movement. Now this is a J1 movement which tells you that it goes front and back in its structure. See here how it goes on. And then we have the next movement called as J2 movement. It moves left and right along its base. Because it has kept in jog frame, it tries to move along its base. And then we have the next movement called as a J3 movement, which goes top and down. Look at it how it moves on. And along with this 3 movement, we have J4, J5 and J6 movement. So here it shows the J4 movement along the same axis which has 2. And this is a J5 movement to the end effector. And finally, moving apart itself, we have the J6 movement where it moves on. So J1 to J3 are meant for linear movement, and J4 to J6 are meant for rotary movement. Okay, I hope it's clear with all the complete features of the robot. Hope it's adventurous for each and everyone to go ahead. Now, we are going to perform a specific task. As you could see, the job is kept on the table to perform. Hope everybody can see the job on the table. Now we are going to record the position of the job onto the process of this circular motion. So there is a step-by-step process which we are supposed to follow. So before we start with the program, we are supposed to reset the fault. Now my friend Mr. Manigandan is resetting the fault, and then he is going to create a new program. Okay, so now first position, the very first thing is he is supposed to keep the end effector to the first position and record it by pressing the Shift plus F1 key. So that is a step which we are supposed to follow. So we need to record it by pressing Shift plus F1 key. Then next, it has to go to the second position, and again we have to follow the same procedure as Shift plus F1 key. Then it moves on to the next other positions of third, fourth, and then finally to the first position where it started by. Now the movements are ready and the job is also ready to go ahead with the operation. Now all the positions are recorded. Now let us execute the program by pressing Shift plus forward. See, now you could see it. When I press Shift plus forward, the complete program is executed. It has a good movement. And this is completely automated. By this concept, you can also do the job by picking and placing it, or by assembling. Another process can be done by attaching a gripper to this end effector. Hope you all enjoyed this video. Thank you everyone for spending time with us.